We're looking at section 5.2 today of integrating natural logs. There's a couple rules that I'd like you to get written down here, and then we're going to do 4 examples, you practicing those rules to start out. First rule is just saying that the integral of 1 over x dx is equal to the natural log of the absolute value of x plus c. If you kind of recall from when we were working with differentiation, when you derive natural log, you get 1 over x. Okay, so it's just the inverse of that concept. The reason for the absolute value is just simply that we're calling the natural log has a domain that is greater than 0, where x is greater than 0. So that's the reason for the absolute value. Over here, the other rule is just the integral of 1 over u du equals natural log of absolute value u plus c. Again, don't forget the plus c's as you do your integrals today. And again, this would just be with the 1 over u du would be something we'd use for substitution. We'll take a look at that on a few of these following examples. For example 1, we're looking at the integral of 2 over x dx. This one's pretty straightforward. You don't have to use any substitution. One extra step you could do is put the 2 out in front and make this 2 times the integral of 1 over x dx. And I think then you can see how we would use this first rule, that notice the integral of 1 over x becomes natural log x plus c. So we'd have natural log x plus c, and that would be multiplied by 2. So our final answer there is be 2 natural log absolute value x plus c. You'll notice that as you write your answers, and look, check these in the back of the book, you don't necessarily have to have the absolute value. We'll begin to assume that our values for x are greater than 0. For this next example, we are going to use some substitution. So I'm going to just put that substitution off to the side here. It'll be 3 steps, very much like section 4.5 back in chapter 4. We're going to set u equal to 4x minus 1. If we derive that, du would just equal 4 dx. And then recall we want to solve for dx. That way we can substitute in and replace dx and put that in terms of u. So if I do that, dx would equal du over 4. So let's go ahead and do our substitution. We'll replace 4x minus 1 with u. So I'd have the integral of 1 over u. And dx will be replaced with du over 4. Notice we can just move, we can think of this as 1/4 du. We can move the 1/4 out in front. So I've got 1/4 times the integral of 1 over u du. And so notice how that applies that second rule where we can use the integration of 1 over u to get natural log u plus c. So our final answer would be 1/4 natural log. I'm going to change u back into terms of x. So it would be 4x minus 1 plus c. And that would be our final answer for example 2. Again, here we integrated 1 over u. We would have natural log of u, but again, u is equal to 4x minus 1. So we want to put our answers in terms of x. I'm going to erase those 2 examples, and we'll do the next 2 here right underneath those rules so you can still see those. For example 3, we're taking a look at the integral of 3x squared plus 1 over x cubed plus x. You'll kind of start to notice a pattern here that if the bottom, because again when it's 1 over x or 1 over u, that integrates to natural log, if the top is the derivative of the bottom, we want u to equal that bottom value. So here we're going to say that u equals x cubed plus x. And notice if I derive that in terms of x, we get the numerator, it'd be 3x squared plus 1 dx. Solve that for dx. Oops, forgot to put my dx here. Solve that for dx, and we have du over 3x squared plus 1. Let's do our substitution. We'll put u in for x cubed plus x, and we'll put du over 3x squared plus 1 in for dx. So I'm going to move that integral off to the side here a little bit. We have the integral of 3x squared plus 1 over u times, and now replace dx with du over 3x squared plus 1. This one works out pretty nicely. The 3x squared plus 1's cancel out. So I'm taking the integral of 1 over u du. And to finish this up, we can do our substitution as we integrate. We know that the integral of 1 over u is natural log u. And so our final answer here would just be the natural log. And let's replace u with what it was in terms of x. X cubed plus x plus c. And that would be our final answer. Again, you'll notice the book sometimes interchanging the parentheses and the absolute value bars. Again, we just know that our domain would have to be x greater than 0. Let's take a look at one other example, and then we'll give you a break here to work on and try out some of these problems. We'll do a trig example here. We've got the integral of secant squared x over tangent x dx. And again, very much like before, we're going to use some substitution here. Notice that the numerator, secant squared, is the derivative of the denominator. It's the derivative of tangent x. So we'll set u equal to tangent x. Again, our next step would be to derive. So du would equal secant squared x dx. And then solve for dx so that we can substitute and put everything in our integral in terms of u. So we have du over secant squared x. Let's go and do our substitution next. We'll replace tangent with u, and we'll replace dx with du over secant squared. So I'll do that substitution off to the side. We'd have the integral of secant squared over u, replacing tangent with u, times replace dx with du over secant squared. And now we can begin to simplify and integrate. Notice our secant squareds would cancel. So I've got the integral of 1 over u du. And again, using this rule, the integral of 1 over u is natural log u plus c. So here we'd have the natural log of tangent x. Again, replacing u, putting it back in terms of x plus c. And that would be my final solution for that integral. Take a moment and pause the video here and try working on numbers 1 through 13, every other odd on the assignment. You can certainly go a little further than that, but just take some time here to try those out. Okay, our next examples here are numbers 5 and 6. I've got those set up off to the side here. For example number 5, we're going to be calculating the integral of x plus 1 over x squared plus 2x. Again, you're going to probably notice we can do some of the similar ideas as we did in example 4. Again, we're going to set u equal to x squared plus 2x. So we'll go ahead and do that off to the side. Let's do it over here so we can see it a little bit better. So we've got u equal to x squared plus 2x. Du would have to be 2x plus 2 dx, and then get dx by itself. So we have du over 2x plus 2. Let's do our substitution. This would give us the integral of x plus 1 over u, again replacing x squared plus 2x with u, times du over 2x plus 2. Notice we don't have the cancellation right now. However, we could make this look like x plus 1 so we get some cancellation. We can factor out a 2 right here of the 2x plus 2. So if I do that, I'd have the integral of x plus 1 over u times du over 2 times x plus 1. We're going to do 2 steps in one here. We're going to cancel out the x plus 1's and move a 1/2 out to the front. So I've got 1/2 times the integral of 1 over u du. And now we can use that rule with that substitution to finish up this problem. We'd end up by replacing x squared plus 2x back into the, back in for u. our final answer here would be 1/2 natural log of x squared plus 2x. And don't forget the plus c. So that'd be our final answer there. Now notice on the next example, if we derive the denominator, it is not going to match up in any way with the numerator. Okay? So what you have to do here is some long division. Okay? We're going to start off with some long division on this problem. So I'm going to write a note here, and I'm going to do the long division, and then I'm going to erase it and do the integral. So make sure you follow along here. So our long division, okay, this will help us to do this problem. We'd have to take x squared plus 1 divided into x squared plus x plus 1. Okay, again, we're calculating the integral of x squared plus x plus 1 over x squared plus 1. In order to do this, x squared and x squared, we just multiply times 1 to get that to work out. So distribute that. I have x squared plus 1 and then change those to the opposite sign. So the x squareds would cancel out as I do my subtraction. I'd have x and then my 1's would cancel out as well. Notice this would be my remainder because there's nowhere else I can go with my quotient. So again, just doing some polynomial long division. To finish up, I'd say that the quotient is 1 plus x over x squared plus 1. Okay, so that's our quotient, 1 over x squared plus 1. So this quotient is what we will integrate. This is an equivalent representation of this fraction that's in our integral. So I'm going to erase this long division, and we're now going to integrate 1 plus x over x squared plus 1. So if I do that, integral of 1 plus x over x squared plus 1 dx. The 1 can be integrated normally. The integral of 1 would just be x, just using the power rule. Okay? And in fact, sorry, before I do that, let's split this so you can visualize that. We'd have the integral of 1 dx plus the integral of x over x squared plus 1 dx. This integral, again, is pretty easy. That would just be x. I'll leave that there for a moment. Here we can use substitution again. U would have to equal x squared plus 1. Du would equal 2x dx. And then solve for dx. That would give us du over 2x. So we can do our substitution to allow us to integrate this part, x over x squared plus 1. So we're still working on that integral. I have x over u times du over 2x. Notice my x's would cancel, which will allow us to integrate here. And we're going to move the 1/2 out in front. Just keep this x as it is, plus 1/2 times the integral of 1 over u du. And now I can integrate this as the natural log of u, which I'll substitute x squared plus 1 back into. So my final answer would be x plus 1/2 times the natural log of x squared plus 1 plus c. So here's our final answer for example 6. Pause the video for a moment here, and I want you to continue working on your assignment. Number 17 is a problem you'll have to use long division. So I want you to try that out right now, as well as continuing on 1 through, I think it's 35 every other op. You can keep working on those. Pause the video and go ahead and work on that now. All right, here's our last example for the day. It's number 41 out of the book. This will help you on number 43 and 49. It just asks you to solve the differential equation, and the equation we're given is dy over dx equals 4 over x, and we want to write this equation through the point 1, 2. So what that means is we will not end up with a plus c. We'll be able to solve for c and have a definite integral. One step I'll do here is just multiply the dx over to remind myself I'm integrating in terms of x. Okay, so I have dy equal to 4 over x dx.